Let's talk about the equation for the speed of light. This is the general equation for the speed of a wave. In the last quantum physics video, we used this equation on an electromagnetic light wave, and we figured out the speed was approximately 3 times 10 to the 8 meters per second. This right here is approximately the speed of light. Now, anytime you're dealing with light, this is always going to be the speed of your wave. Now, this might be confusing because you might be thinking to yourself, well, if the wavelength or frequency could be different, doesn't that mean this number wouldn't be constant? Because wouldn't a different light frequency or a different wavelength change your speed? And that's actually not true because the wavelength and frequency are inversely related to each other. So for example, let's say that we have a much bigger wavelength. Notice the wavelength has increased, but the frequency has decreased. Notice it oscillates fewer times, so the frequency's actually gone down, but the product is still going to equal approximately 3 times 10 to the 8 meters per second. But now let's go ahead and say that we have a much smaller wavelength, but now the frequency is oscillating very frequently. It's oscillating a lot. I don't even want to try and draw that. So even though the wavelength's gone down, the frequency has gone up, but the product of these will still equal the speed of light, which is approximately 3 times 10 to the 8 meters per second. So this is the equation for the speed of light.